Hello, welcome to my session about testing, and integration testing with test containers. The last session before lunch. Everyone will be very motivated, I think, so let's get started. A little bit about myself. My name is Kevin Wittek. I'm actually substituting my colleague from Atomic Jar, Oleg, who was supposed to give the talk. But then this conference got rescheduled, and he asked me, can you do it? And yes, I like to do it, and I always love to talk about test containers. Last year, we founded a company based on test containers, around test containers, and around building products for test containers, which is called Atomic Jar, and there I'm a software engineer. One of the products we are developing there is Test Containers Cloud, but I will not speak too much about it. I will just implicitly use it in the demos, but everything we will see you can use with normal local Docker as well. And in theory, I'm also still a PhD student, but in practice, maybe not. And sometimes help my wife with doing research with pigeons, behavior science. That's cool. And I'm one of the maintainers of the Test Containers open source project. So I hope I can share some stuff from the library and the open source project with you, and you can learn from this. And I'm an Oracle ace also, which before was Oracle Groundbreaker ambassador. All right, before we look into integration testing and into test containers, I'd like to a little bit travel back in time and think a little bit about how we actually define unit testing and what is there in the context of unit testing and how it's shaped in the history of time. And one of the defining figures, at least in the Java community, seems to be to me at least, Kent Beck. And there was a very good podcast, Software Engineering Radio, where he talked about the history of JUnit, and it is also a little bit the history of unit testing, how we know it in Java development terms. So Kent Beck comes from the Smalltalk community, and in the Smalltalk community, they already had a very strong testing culture and testing background, yes? But in Smalltalk, you didn't test like we do it nowadays with JUnit, with this automated test and so on. No, it was much more interactive, and if any of you have used Smalltalk or other languages like MATLAB or R, you might know these very stateful workspaces where you run code in your workspace and this changes variables in your workspace, and then you just assert by I that the state is the state you wanted to have. So that's how they used to do testing there. And so we had the stateful workspace structure. And then he developed an object-oriented unit testing framework around this idea that was supposed to be more automated, yes? So the idea was that this workspace becomes your test suite, and you have then the classes, and the things they before run by hand become the method in the classes, and we have like the asserts in the code instead of looking at the actual print statements and debugging by eye. And that's what he introduced in the C3 project, which is this famous project where all those testing people and agile people then work, where also extreme programming was born in a way. And it worked well for them there in the 90s. And then there was this famous flight where Beck flew together with Gamma to the Uppsala conference, and on the flight they developed JUnit already doing TDD, and then when they arrived they gave it to Martin Fowler, and Martin Fowler said also, oh, that's a cool thing, let's maybe spread this. And that is a little bit how our idea of unit testing came into the Java community and into the software community as a whole to a certain degree. So I'm personally a very big fan of TDD, of test-driven development. And the interesting thing is that if we talk about TDD, we often think about unit testing only. But Kent Beck himself said TDD is never intended as a unit testing methodology. And you should always think about testing at the different scales. And as an example, the JUnit test suite, which has been developed using TDD style, consists of roughly 40% tests through the public API and only 60% tests of the lower level object. And those 40% tests of the public API, they are probably not what you would characterize as unit tests. They are what you would maybe characterize as functional tests or whatever, something different. We don't really have those clear definitions as an industry, sadly. And then they realized something after they developed JUnit and brought it into the programming community. So traditionally, and maybe still today, developers don't like to test that much. I don't know. I don't know how it's about you, but when I started programming, I wasn't that big of a testing fan, at least. So then they realized something when they showed JUnit to them. Like, remember, back then there wasn't even JUnit. You would test by just manually asserting things and so on. Then what they say here is they found the outside influence we needed in a simple testing framework. Lets us do a little testing that makes a big difference. So to advocate testing for the developers, they found out that JUnit as a tool is a very useful thing because it makes testing much more enjoyable. You can approach it with a programmer's mind, and that's what they learn when they coach people to do more testing. Okay, and yeah, so this is a question I can ask all of you, or I can ask myself. Why do you test? Why do we test as software developers? Yeah, maybe retroactively to find bugs, and then once we have our specification down to safeguard against future regressions. But some maybe just test because the boss told them, oh, you have to rate tests, you have to have 95% test coverage. That will likely not lead to very good tests then, because you just write them because you had to, you don't see the real value in this. And some will even say, like, okay, as a programmer, as a developer, I don't have to test because that's why we have testers. And I personally, for me, testing is just part of the normal development, because testing is the best way to get feedback about my code, about the code I'm developing while I'm developing it. And yeah, to get this benefit, there is a nice quote for Martin Fowler that tells when is a good time to write a test. Whenever you attempted to type something into a print statement or a debugger expression, write it to a test instead. Yes, so that's a good example. And then this leads to two phases during development that have a very high return of investment for writing tests, and that is during the actual development, doing something like TDD or very similar, at least writing the test while you write the code. It doesn't have to be strictly TDD. And then also, if you are doing debugging, try to write a test for the bug first and then fix against the test. Yes, so we talked like a little bit of your unit testing and so on, but what is actually unit testing? And it's just something I discovered while researching the definitions of unit testing a bit. And it seems the term suddenly appeared and then shifted the meaning also a little bit. And the earliest mention of the term unit testing I found is in a paper from the 70s, 78, Automatic Software Test Drivers by Pencil. And he referenced there a manual from IBM, which is even older, in the 60s or 70s, Automated Unit Test System. Okay, a reference manual. And I couldn't find this. So I don't even know what this manual is supposed to mean with regards to unit tests. But it could mean the unit of code you execute as a test, or it could mean the unit under test. It's not really clear from those papers. And then something interesting I found out. So in '79, we had a book come out, The Art of Software Testing, which was quite famous in the software engineering industry and the testing industry. And there is a chapter on module testing. Okay. Then in the 90s, we have the rise of all those X-unit frameworks from the Agile communities, from the extreme programming communities. And their unit was very often defined as a unit of test code that can be executed, not necessarily the unit under test. And then something interesting happened. The new version of the software testing book renamed the chapter on module testing to module and unit testing, but the content didn't really change. Yeah? So that I found very interesting how the meaning of unit testing suddenly changed over time and just, I don't know, accidentally cargo culture like through the industry. When we talk about testing, we also always have this testing pyramids in mind. And when I looked a little bit into the origin of the testing pyramid, there are some indications that the origin might be the food pyramid. Here, this is the original food pyramid from the United States Department of Agriculture. And we, of course, nowadays know that this is not necessarily scientifically correct, and it was sponsored by the Department of Agriculture, and that's why we have so many agriculture projects there at the base. So it's kind of lobbyism, yeah. And that's very interesting. And yeah, this kind of transitioned as a metaphor into the software world. It seems, we will have a follow-up example where it's even, I think, more visible, that this is the origin. And this is one of the first occurrences of the testing pyramid I found from allegedly from 2003 from Mike Cohn. And there are no primary sources of this, but Martin Fowler says that Mike Cohn showed the testing pyramid at some conference to Lisa Crispin, who later did the testing quadrants. And this was around 2003 at some Scrum or Agile conference. And then he writes about it in 2009 in his book, Succeeding with Agile, Software Development Using Scrum. And important to know is the context of advocating for the pyramid back then. So we are at a time where Agile is still a thing people are actively advocating for. And there was the notion, especially before those Agile movements, that tests are very expensive to write and expensive to maintain. And that's why you need dedicated departments for this. And that very often automation was not considered as at distinct different levels, and thinking about what are the needs of the automation on those different levels. And then Mike Cohn proposed this idea of this testing pyramid and thinking about the different levels. And UI test in this case means, of course, something like Selenium. And then for service test, what he means is very, very fuzzy in his definition, but he means something like probably testing through some public API that is not the UI. And he gives an example for a service test where you have a calculator and there is a multiply service and an addition service, and you test those. And that sounds for me like a very strange example for a service test, because what is a multiply service going to do? That sounds like a pure function, so why wouldn't this be a unit test? So we see a lot of what is written about this stuff is so simplified that in practice it's then very hard to define what kind of test class we're actually dealing with. And this around the same time appeared from Jason Huggins, who is the inventor of Selenium. And what I like so much about this drawing is that at the top he says, okay, UI test, it's salt and fats used sparingly, okay? And that's why I think it originated from the metaphor of the food pyramid. But the rest is very similar to how Mike Cohn saw it. The Martin Fowler variant from 2012 is already a little bit more interesting, or I like it more because it adds a little bit of context to it. The other ones were a little bit context-free, but here we say, okay, this pyramid is valid under the assumption that the unit tests run faster, UI tests are slower, and accordingly unit tests are cheaper to write and to maintain, and UI tests are more expensive. But there is a very, very interesting quote in here already. If my high-level tests are fast, reliable, and cheap to modify, then lower-level tests aren't needed. So that is the context of the pyramid back in this time, 2012. Yeah, then we have a couple of different variants, people iterating on the idea. This is from Simon Brown, 2014, with this house shape, already like the composition changes. And then 2018, a blog post from Spotify comes out, testing Honeycomb, and this is extremely interesting, because suddenly they say, okay, for our microservice, we use mostly integration tests, because the integration tests give us the best confidence, give us the best flexibility to do refactorings, and we have very decoupled tests that are very decoupled from our actual code. That gives us, more, as I said, more flexibility for refactorings. And they say in this blog post already, they themselves utilize test containers for doing it, for having the integration test heavy code base that still is very reliable. And we have different iterations on this idea. This is from Asaf Mesika. He calls it the diamond model, but similar concept to the honeycomb model, with a lot of integration tests being the main focus of your test suite. And from the JavaScript community, we had the idea of the testing trophy. The top looks like the honeycomb or the diamond, but it also considers the concept of static checks, like you would have in a statically typed language, for example, because they also test the code in a certain way and can find certain error classes. All right. Okay, that being said, we saw those pyramids, and they look two-dimensional, but they are actually a one-dimensional representation of where you would put a test. And I would personally say having this one-dimensional scale that just goes from bottom to up on the y-axis is not really useful to classify our actual test. Yeah, so because that's what I learned when I talk with people, what is their understanding of unit test? What is their understanding of integration test? It differs between people, it differs between teams, it's not really clear in our industry. So there seems to be the notion that there is unit integration test, but we don't really can define this. But if we look at other dimensions, we have something like opaque box and transparent box. So do I have to look at the state of my application only through public APIs, or can I look into my application state from within the application? This is often correlating with in-process tests with out-of-process tests. Out-of-process tests where I just can interact with my application through the REST API, for example. In-process test, if I have a classic Spring Boot test, I'm inside the same JVM process. That gives me completely different capabilities for testing strategies. And then I like this idea from Martin Fowler a lot, solitary versus sociable test. That just means if my system under test or my object under test interacts with other components or not. Yeah, so if I have to mock it out or if I can use the real components to interact with. Yes, and to bring this slide a little bit in a condensed form, I personally would say an integration test is something where we interact with external processes, where our code interacts with external processes. So mostly examples like interacting with a database, interacting with a messaging system like Kafka and so on. These are integration tests for me. If I have two objects in memory talking with each other, that's not an integration test for me. And but still, Martin Fowler has a very nice thing to say about this, about external components and unit tests. If talking to the resource is stable and fast enough for you, then there's no reason to not do it in your unit test. So he has a different definition again. Yeah? Talking with a database is fine for him in a unit test if it's fast and stable. Okay, so going back to the idea how JUnit could influence our thinking on testing and how we approach testing because it made it easier to do the right thing. I'd like to say that maybe test containers can also be a similar tool that can influence how we approach testing and how we approach the composition of our testing pyramid. So yes, now we come into the part that becomes a little bit more concrete. We want to talk about test containers, the open source library, and let's look what you can do with test containers. So this is the vanilla API, so to say. It's just the direct object-oriented Java abstraction. So test containers in a nutshell is there to instrument Docker containers as part of your test, as part of your test lifecycle, to spin up your test environment on demand while you run the test, so they are there then. And here we have an example where we see, okay, there's this concept of a generic container object. You just specify any kind of Docker image there, you configure it a little bit, say I want to interact with this port or that port, and then you can just start it, you can stop it, you can do with it what you want because it's just an object in your test. And some important things we already see here happening, or we can learn here. So when we call start, this is not like doing a Docker container run Redis, because if I run with Docker, it will just create the container process and then Docker considers the container started. But test container has a bit more of the notion of wanting to wait for the application inside the container to be ready. Because for your tests, you generally don't want just the container process to be started. You want to have the database inside ready, so your tests can start interact with it, so you don't have race conditions. So the start method will automatically block until the container is considered ready. How does test containers determine what is considered ready? As a default, if you don't configure anything else, it will just wait until it can open a TCP connection to this port. But you can also configure much more sophisticated wait strategies, like waiting for a certain log message or waiting for a certain HTTP response, and so on. All right, then when I expose a port like this is not like doing this fixed port mapping in Docker where I would say, okay, map port 6379 to 6379 on my host. No, this is like publishing the port, which will then automatically open the port, map the port to a free ephemeral port on the host, so something about 50,000, above 60,000, so we can be sure there are no collisions with other services running, with other tests running, with other containers running. And then we just have an API that you can access to get the actually dynamically mapped port after the container has started. Another cool thing, when I do the stop there, Afterwards, Testcontainers will automatically clean up all the resources it has created, so you don't have to take care of zombie containers lying around or anything. But you don't have to use it directly. You can also use it with different test framework integrations we provide. And this depends on your use case, if you want to use it or not. It's absolutely not necessary. The direct usage is very fine. But if you fancy, you can use here this example is a JUnit Jupyter integration. So you annotate your test class with the test containers extension annotation. And then you annotate each container defined as a field with the container annotation. This tells the test containers extension that it should instrument these containers, the container lifecycle. And then this means each container is started and stopped for each test method. Or if I would make it a static field, it would start and stop per test class. And we will see in the demo how this works out. But of course, this might be non-optimal. Like restarting a container for every test method, that is a little bit expensive. It's better than with a virtual machine, but still a little bit expensive. Okay, some more basic facts about the project itself. So test containers, when we talk about test containers, people generally mean test containers Java, because test containers Java is the main implementation, the main project. It's also how everything started. In 2015, test containers Java was first released from Richard North. He's standing there in the middle, and it's under 100% open source license. Under MIT license actually, and this also will not change. So although we are now a company, Atomic Jar, that helps in maintaining test containers itself will stay open source, and we are building products that use test containers, so to say. There are 56 releases and 333 contributors in total, so many contributors from the community. And if I look into the stats of GitHub, I see it's used by 8,200 other GitHub projects. Yeah? And yes, the core maintainers, Richard in the middle, then Sergey on the left, and I joined as a third person on the right. And just recently, Edu also joined the core maintainers team, and yeah, that's how it works. But of course, there are also others that are not directly core maintainers, but maintain specific functionality, specific modules, etc. I said test containers Java is the main language, the main variant, but there are also implementations in other languages that came up. So we see there's test containers Go, test containers Python, test containers Node. These are all more or less re-implementations, so we don't have shared code or shared components, except maybe some Docker images that are shared across the project. And Docker Java is the most feature complete one, and the others try to just follow the concepts and also try to bring some of the concepts into a more idiomatic way into their language. But especially test containers Go is also used in many open source projects I know of, and test containers Node is also widespread use in the community. This year, something nice happened to test containers, that we appeared on the ThoughtWorks technology radar, and not just anywhere, but in the adopt section, which is basically the best part open source technology can be in. And that is what ThoughtWorks says about test containers. We think it's a useful default option for creating a reliable environment for running tests. Our teams have consistently found this library of programmable, lightweight, and disposable containers to make functional tests more reliable. And yes, I'd like to agree with ThoughtWorks, and very happy that we are there now. Some of the features test containers provides is, we already saw in this example, that we have this generic container abstraction, so you can just put in any Docker image you have, anything you build yourself or anything from public Docker Hub, and you can use it. But there are also some modules that are custom abstractions over certain technologies, like containers for databases, container for Kafka or Pulsar. And what they do, what they provide is they just configure the container already optimally for the image and for the testing use case, like having the correct weight strategy, setting the correct environment variables, etc. And they provide some nice syntactic sugar like API methods that make interacting with the container a bit easier for your test code. We support the cloud mock offerings of the big clouds, where they have those emulator images. Like for AWS we have local stack, and for Azure we have Azurite, and so on. And Google Cloud has something similar. And yeah, this is a mock in a sense, but still running it as a container, as a test containers, is quite nice because it runs as its own process. You're still using the real clients to interact with it, and it gives you quite the good confidence, I would say, over using like real mocking with something like Mockito or so. So if you're already using Docker Compose, you can also reuse your existing Docker Compose file. Just point test containers at it, and it will spin up the containers there. But in general, we would advocate that it's better to use test containers directly. It's more flexible, it's more robust, and you can also use it to replace it for local development use cases. Like some would maybe use Docker Compose just if they want to do local interactive development. You can also use test containers just for this kind of instrumenting of containers. You don't necessarily have to bind it to actual test lifecycles. Support for testing with Selenium, where we would launch the container with the browser running in the container in a more or less headless way, but you can also record videos. Chaos testing support is cool with ToxiProxy, where you put it as a TCP proxy between containers, and then you can introduce toxics like dropping packages, adding latency, jitter, etc. Support for Kubernetes with K3s or kin container, so that you can then deploy your Kubernetes application into this Kubernetes running in Docker to at least check if your Helm chart is working or whatsoever. And yes, many, many more modules. Dynamic port binding is what I said, that we don't map onto fixed ports, and that's very, very good, because then you can't have port conflicts. That makes your test much more robust. But people have to sometimes rethink a little bit how they configure their system under test, because they are so used to maybe hard coding some test database URL somewhere in a config file. If you're having dynamic ports, dynamic resources that just spin up while your test execute, you have to think how to inject it into your system under test. But that is possible with all the frameworks. Spring Boot has special support for it even. And yes, you just have to find out how to do it for your use case, for your test framework. Wait strategies, I already mentioned. Test containers wait for the application readiness, so that a certain port is ready, a certain log message has been written, or that a certain HTTP response, we receive a certain HTTP response. And when you have some way to access Docker from your machine, that's all it needs. You don't need to configure test containers in any way. It will automatically discover your Docker environment and configure it accordingly. So it doesn't matter if you're Docker desktop on Mac or Windows, or you're having a native Docker installed on your Linux, or you're having a remote Docker host that you configured with Docker host environment variable. Test containers will automatically pick it up. Therefore, also platform independent and works on all the major operating systems out of the box, at least if on Mac and Windows you use Docker Desktop, so that is a mainly supported Docker variant there, and you don't have to configure anything for this. Yeah, a list of all the modules we currently provide in the library, but I'm not going through all of them. And if you are wanting to use a technology for which there isn't yet a test containers module, the chance is high you just don't need a specific module for this technology, because you can just use the image directly using generic container. Yeah, so then it's completely fine. All right, so, and I have some time left for the demo, and let's look at some code. Okie dokie, I go into presentation mode. Okay, so so if you now want to get started with test containers and you already have Docker on your machine, all you have to do is add the test containers dependency to your Maven or to your Gradle. We also have here this BOM, this bill of materials. If you add this, you don't have to specify all the versions for the distinct test containers modules. Like in this case, I'm using the Postgres module, the Oracle module, the Kafka module. And when I have the BOM here, I don't have to specify the versions, else you just have to replicate the version across dependencies. And now we will look at a very simple example application that does nearly nothing, but it shows us how to interact with it even without any framework. So I purposely did it without any kind of framework. So we have just a record here, a book with two attributes, name and author. And then we have here a book repository that interacts with a JDBC resource to just save books, and the code is not that important, just the testing is important. Yeah? So it can save books, it can count the books, it can search for books, and all just using plain SQL statements. And then here we have another class that can send out messages. Actually, just generic messages can be sent out to Kafka, and yeah, that's it. Yeah? So nothing so useful we are doing here with the application, but it allows us to just think about, okay, how can we integration test those different components? All right, so let's get started with the book repository example. So here we see I'm using the JUnit Jupyter integration. That's why I have annotated it here with add Testcontainers. And here I have a field. And this is now not generic container, but it's one of these special modules, the Postgres container. And I have annotated it further with add container, so it gets instrumented by Testcontainers. And the way this is now set up, it will, before every test, start a container, after the test, stop it, and then for the next step, start a new container, like a brand new one. This is, of course, like a very, very heavy approach, but you get a new infrastructure for each test method. Yeah, so you don't have to think anything about test pollution, but it's a very high price to pay against test pollution. We will look at some better patterns, but let's just, for the sake of it, run it and see how it feels. So further in this setup block, I'm just initializing the schema, and then I have the test methods here. I check the empty repository is empty, and I can save a book, and I can search for books. And we see already here in the background the tests are running, and it takes a couple of seconds for each test, because each test now spins up a completely new Postgres database, initializes the schema, and then interacts with it. That's why each test has a little bit of overhead. There are some other nice things we can already see here. So my book repository I created in such a way that it just gets a constructor parameter for the JDBC URL it should connect to. So if you have code you control yourself, just having some way of dependency injection, like constructor dependency injection, to specify URLs for your external resources, very, very easy to test then. And here we see why. So we can just create this repository object with the JDBC URL. And this JDBC URL is one of those convenient methods Testcontainers provides. So it will already give you the JDBC URL with a map port. So you just put it in your system, and then everything is fine. Same with get username, get password. These are those convenience methods we have in these specialized modules. And if we look at the actual implementation of JDBC URL, we see it's quite straightforward. So we just concatenate a JDBC string. We get the IP address of the container, although this means the IP address under which the container is reachable, not the actual IP address of the container. And then the map port. Yeah? And if you would do it yourself, you could, because you may be using generic container, it's basically something like database container get host. Yeah? That is like the new method. Get container IP address is the deprecated one. So it's get host, and then we have get map port 600, something like this, and you concatenate a string out of this. So that's always the idea to get the actual connection location. Okay, so now let's improve the timing a little bit. Already when we make this here now static, it should become much better, because now we will reuse the same container for every test in this test class. Yeah. Oops. Yep. Okay, so now it's much faster. We lost this initial overhead. That was like 5 seconds, 5 second startup overhead for each test method. And yeah, now it comes down to acceptable levels. I can also run it again, and while we run it, we look at the PowerShell here. So at the Docker, this is basically Docker PS. So we see container is started. This is like the Wait, I can do docker ps, maybe nicer, or it's already stopped. Let's run it again. Okay, so here we see the Postgres container was started. There's also this reu container. It's like this sidecar helper container, test container launches that does the cleanup afterwards. And yeah, we also see here how everything got mapped to this high ephemeral ports. And then after the tests are run, all the resources are gone. Everything is nice. If we look at Kafka, the example is basically the same, just for Kafka. Okay, I'm also using the JUnit integration here. And I'm just starting the container, and then I'm sending a message there, and I'm just polling in a consumer to wait until the message is received. So we see here the logs. Kafka is starting. Yeah, was pretty quick actually, like 10 seconds. 10 seconds for starting Kafka, for starting Zookeeper. Yeah, that's quite cool, I think. And yeah, this is the Kafka container, the special abstraction that makes it easy to run Kafka as a container for your tests. And if we look into the actual implementation here, we see this is a bit more involved. So this is like setting all the environment variables in a way that it makes sense for the test. So you could do the same with generic container, but then you have to do a lot of things. And Kafka container tries to bring you these best practices, so you get them automatically, and it's easy to use then. Yeah? So we configure the image accordingly, and then there are some very, very tricky things we have to do here for Kafka, like Kafka allows you to use an embedded Zookeeper inside the container, so we might need to start this as another process. And then with Zookeeper, you have the big problem that Zookeeper wants to know the port under which it should advertise the listeners before starting. And since we don't know this until the container has started, we basically have here a callback method, which is this one, container is started, that is executed by the Testcontainers library. So here we can wait after the container has started. We inspect what is the actual dynamically mapped ports, and we can reconfigure Kafka and Zookeeper to give you the correct port to which to connect. And everything is fine, and you don't have to worry about those very specific, intricate details of the actual image there. All right. And now let me show you one last example. And yeah, by the way, I'm now not using my local Docker. I'm having this small icon here. This is Testcontainers Cloud. So this is one of the products we're developing, but you could do everything exactly the same with local Docker. Just when I'm using Testcontainers Cloud, all the containers are not starting on my local machine, but transparently in the cloud. That's also why I have, it's a little bit slower here right now because my Wi-Fi connection is not perfect and I have a little bit of latency there. Yeah, it's a complete drop-in replacement. You don't have to configure anything for test containers. And for the test code itself, it's completely transparent still, yeah? So now let's, and it feels like everything is on localhost for the test code, yeah? So now let's look at another example. We had the same as we had with Postgres, we're now doing with Oracle. And we have an Oracle container abstraction. And this works with this image from Gerard. Jevensel Oracle XE image, which is a very nice Docker image for using an Oracle database. And let's start it, and it will now take a little bit longer than the Postgres test before, probably because starting an Oracle takes a little bit longer, so maybe 30 seconds, maybe even a minute. Yeah. So, yep, we see the database is starting. And if we look here at the Docker PS, so we see the database is already up. And if you would just do the Docker run, then you would think, okay, container started, let's talk to it, yes? But it takes like 1 minute until the actual database inside starts up, and then you can interact with it. And yes, so this worked. So we had this, 30-second overhead for starting the actual database. And then afterwards, each test here is reusing the database. And it's a bit faster like this. OK, but if I'm now doing some TDD-style development, like debugging my SQL queries or whatever, having this 30-second initial overhead still feels like too much to me. So what we can do, we can use the experimental reusable mode from test containers. For this I will say with reuse, and then the container will survive the life cycle of the JVM process, so it will persist even once the JVM exited. As a default, the maximum life cycle of a test containers instrumented container is always the JVM process life cycle. And I furthermore don't use the the JUnit Jupyter integration here. I start the container by hand, and I can also call start an already start container. That's just a no-op, so completely fine. I never stop it. Okay, then it will just survive running. And before it got removed, although I never called stop. And that's because, as a default, when JVM exits, all the containers are cleaned up. Now let's run it again. And the first run should be like before, because now for the first time we have to start up the database. Okay, and there we see it coming up. Okay, and here we also see it takes a lot of CPU here starting up. It also should at one point start using more memory. Yeah, here now the memory usage goes up, and now depending on how you test and how many, how strongly you want to parallelize. Maybe you want to run 4 tests in parallel, but they should all use their own databases for whatever isolation and so on. Then this would become a problem when running it on my local laptop here, especially since I'm on Windows. There it's just a VM, the Docker environment, and it's the same on Mac. It's just a VM. But since I'm now using Test Containers Cloud, I can basically scale out the running of the container resources. That makes it a bit nicer, and I can parallelize more by this also, then save time for my test suite. So tests are over, and we still see the container here running. And again, we saw here we had the 30-second overhead initially. So let's run again. And now we would expect to not have the 30-second overhead. And indeed, we don't have it. We don't have it. And yeah, so we still do the database migration for every test method and so on. So it's just a simple example. Depending on your use case, you can, of course, structure it differently and solve test pollution differently. But this is a very good approach for making it more enjoyable to test against containers, against images that have a longer startup time. All right, cool. So yes, so the idea behind test containers is we have everything defined as our code. So if a new developer comes into a team, she will just clone the repository and can just run everything. Doesn't need to set up anything herself, doesn't need to follow any Wikipedia pages that describe how to set up this database and this Kafka and how to configure it. And you don't have to remember to run the Docker Compose before the tests start, because everything is connected and everything has your actual tests you already used, your automated test, as the entry point. And yes, so that's it from my side. Thank you very much. We have some time left for questions, and I'm happy to answer them, if there are some. Okay, no questions. Thank you very much, and have a nice lunch.